Okay, so what we're going to look at next are trig equations. So trig equations are a step on then from our unit circle. So what we've already seen is that there are four different points on our circle where the sine values or cosine values or tan values are the same, but maybe one is positive, one is negative. So the actual positive negative part of it might be different, but the numerical value will be the same. We kind of explored that in the previous video, so if you're not maybe sure what I'm talking about, you might want to just quickly go back and kind of skip through that one. But this is what we are looking at here. So if I was to pick four different points with essentially the same angle to the horizontal, okay, so that angle theta there from the center to the horizontal, and we could see then that each of the points would have the same coordinates, so still x and y at every single point, but in some cases it was minus x, in some cases it was minus y, depending on where in our coordinate axes we were. And what that did was it impacted then on the value that we got for our cosine and our sine, whether it was positive or negative. But the angle that we have to the horizontal there, that acute angle, stayed the same regardless. However, if we look at the point Q there, in terms of getting that actual angle, really we start from here, from kind of this point on my x-axis, and we consider it nearly to be pulling around the whole around the circle past 90 degrees until I get to Q. So really that angle is not the same angle, but we look at this small angle, and we had a particular name for that in the last section. We called this the reference angle. So we consider this to be our reference angle. So it's the angle that's the same as the one that we had in the first section. But really the main thing to think about, I suppose, is that there are four different quadrants, and in each of those quadrants we have a value for sine of 60. Okay, we can take a reference angle of 60. So we can use our cast circle and our reference angles to solve trig equations, and usually we'll have two solutions. Okay, so first of all we want to identify the quadrants where the answer is. So we look at the sine. So from our sine we can see whether it's going to be in the first, second, third or fourth quadrant, and that again was something we looked at with our cast circle. Then we're going to ignore the sine. So once we know which quadrant we're looking at, we're just going to ignore the sine. We're going to find our reference angle. We're going to find the reference angles. Then we sketch in our reference angles on the unit circle, and we identify the two solutions by finding the angle. Okay, so we'll find our reference angles, and then we will sketch them onto our unit circle in those particular quadrants, and we'll use them to find the angle from 0 degrees, so the actual value of the angle. So let's see how that works in practice. So if I have a question here, sine of x is equal to minus root 3 over 2. So for some angle x, they've told us x is between 0 and 360, for some angle x, sine of that angle is minus root 3 over 2. So first of all, our first step was to look at the sign of my answer, and we can see that for this question my answer is negative. Now sine is negative in two quadrants, and those two quadrants we've marked in here are the third quadrant and the fourth quadrant, so the T and C. So obviously they're all positive in the first one, and then sine is positive in the next one. So what that means for us is that when we're thinking about our angle, and if we think about it as coming from kind of the origin and going the whole way around, so kind of following like the pencil is there and following around and going on around, our angle from that point 0 all the way around will end up in the third and the fourth quadrant. Like we said at the start, we're kind of expecting two values. Now what we need to do is find our reference angle. So if sine of x is equal to minus root 3 over 2, my reference angle, which is the one in the first quadrant that I'm going to compare it to, that angle in the first quadrant, always all of the answers are positive. So we're going to ignore the sine, and we're just going to say that for my reference angle, the answer is just root 3 over 2. Okay, we ignore the sine because we're comparing it to that angle in the first quadrant. So there's some angle in the first quadrant which has the same numerical answer. So sine of my reference angle is root 3 over 2, which means my reference angle is sine inverse root 3 over 2. Okay, and we can do this using our calculator, or we can use it using our log tables, because a lot of the angles that they want us to do in these kind of exam questions come from our log tables, but we can use our calculator for this one. So let me just get it. So sine inverse root 3 over 2, and again this is really one that we should probably know, but let's just double check. 60 degrees. Okay, so my reference angle is 60 degrees. Now what I need to do is I need to sketch a diagram, okay, with my axes, my unit circle, my axes. Lovely. My reference angle is 60 degrees, and we know that our answer is going to be the angle in this quadrant and this quadrant here. So let's draw them in. First of all, draw one in here and one in here. Remember that our reference angle is the acute angle, so the small angle to the horizontal. So 60 degrees to here, and same here, 60 degrees to here. Coming back again to what we looked at in the last one, so always to the horizontal, and to do with kind of making those x and y values. Now we need to find out what is the complete angle here. So let's start off maybe with the blue here. So we'll maybe let this be the blue one. So starting from 0 here and going all the way around past 90, past 180, and on round until I hit my line here. So let's just mark in those 90, 180, this is 270, this is 360, going up in 90s. So looking at my blue angle there, I've gone past 180 and then 60 degrees more. So my blue angle is 180 plus 60, which gives me an answer of 240 degrees. Then if I do the red here, so I'm going round, round, past the blue one, on round until I get to this point here. And we have two ways of looking at this one. The quickest way is to think I'm going the whole way minus 60 degrees. I'm stopping 60 degrees short of being the full way around. So what that means then is that x is equal to 240 degrees, or x is equal to 300 degrees. And if we wanted to check for ourselves in our calculator, we could type in sine 240 and we'll see that we get an answer of minus root 3 over 2. We can check it that way for ourselves. And the same thing with sine of 300. We get the same answer. So all that means is for 240 and for 300, they have the same sine value as sine of 60. And there'd be an angle in the second quadrant that would have the same value as well. Let's try another example. So cos of x is equal to minus 1 over 2, minus a half. So let's try this one. So same thing again. First of all, I need to look at the sign and see which section that's going to pop me in. So thinking of my cast circle, cos is negative for this question. So my answer is negative, which means that I'm looking in this section and this section here. Okay. Now I need to look for my reference angle. So remember, for our reference angle, we ignore the signs. We just get rid of it because our reference angle is 1 in the first quadrant. So my reference angle is cos inverse of a half, which is again 60 degrees. And we end up again with something similar. So we can draw a sketch. We can fill in our angles here. We can make a note of our reference angle, and then we just draw in the same way. So for this one here, it's going to be 180 minus 60 this time, and that's going to give me a value of 120 degrees. And for my blue then again, starting from here, working my way around, we get the same answer that we had the last time. So 180 plus 60 be 240. So x is equal to 120, or x is equal to 240 degrees. So our two answers there. Again, another question here, so tan this time. So we can do the same thing again. First of all, our sign, positive. Okay, so where is tan going to be positive? Well, we can look at our cast circle again, and we'll see that tan is positive here, and tan is positive in the first quadrant, where they're all positive. Then same thing again, so we said we ignore the sign, so we just leave it being positive. So to find our reference angle, so tan of my reference angle is 1 over root 3. So my reference angle, or then, is equal to tan inverse 1 over root 3, which gives me 30 degrees. I can draw my sketch then. So we're following the same method each time. I know my answer is going to be in this quadrant and this quadrant. Fill in my reference angle, 30 degrees. And then first of all, my first answer is simply the reference angle that I have, because we said that from the start. Your reference angle is essentially the angle in the first quadrant that you're comparing it to, so that's 30 degrees, and the second angle then go round is going to be 180 plus 30, which is 210 degrees. So theta is 30 degrees, or theta is 210 degrees. Okay. There is another type of question that we need to explore, and it's this one here. Cos of 2x is equal to minus root 3 over 2. Okay, so let's approach this in the same way. Okay, so we're going to approach it in the same way. So first of all, we look at the sign. We see that the sign is negative. Okay, so our sign is negative. What that means for us with our cast circle, we should know, but we'll mark it out again. It means that it's going to be in one of these two quadrants. Then I ignore my sign and I look for my reference angle. The cos of my reference angle is minus root 3 over 2, or not minus, sorry, just root 3 over 2, which makes my reference angle cos inverse of root 3 over 2, which gives me an answer of 30 degrees. Drawing my sketch then, and we're looking at the two sections that we're in. Terrible. That was also terrible. Oh god, all going wrong. Oh no. Okay, cos of 30. There we go. Lovely. Okay, cos of 30. So we fill those in. 30 degrees here, 30 degrees here. Okay, so those are my two sections I'm looking at. For the first one, mark it out here, and I get that my first angle is going to be 180 minus 30, which is 150 degrees. My second angle then is the one that's going the whole way around there, which is 180 plus 30, which gives me 210 degrees. Okay, now here we have to be careful of the question. The question this time referred to 2x. So what we have is 2x is equal to 150 degrees and 2x is equal to 210 degrees. Now generally, we should be familiar enough with that we don't usually look for 2x, we usually look for x. So let's find x. X is 75 degrees, or x is going to be 105 degrees. And really those would be our answers. But we can see, when did we decide to divide by 2? We didn't divide by 2 until the very end. Until we got to the very end there, we didn't divide by 2. So we still took our reference angle as normal, and we still found out our answers as normal, and then we divided by 2 to get our values of x. Okay, so waiting until kind of the last minute there. The final one we'll look at is this example here. If tan b is equal to 1 over root 3 and sine of b is equal to minus half, express cos b as a surd. Okay, so an interesting question for us to look at. So we have to think about what this means for us. Okay, if I'm told what tan of b is and I'm told what sine of b is, we can think about where those come from. Okay, so if this is my angle b here, and if this is a kind of a right angle triangle, sine is opposite over hypotenuse. So my hypotenuse must be 2, my opposite must be 1. And again, tan is opposite over adjacent, so my adjacent side must be root 3. This is an example of maybe where we might have to use this sort of question to find another ratio. Okay, if they had given us 1, we might have to use something like this to find a different ratio. But for this question, we're just looking to get cos b as a surd. So let's just kind of make a guess at what it could be. We know cos of b is going to be, let's see, what's the value going to be? So it's going to be my adjacent, which is root 3, over my hypotenuse, which is 2. Now the thing we have to be careful of is this part here. Is it going to be positive or negative? And how can we check? Well, we can look at the value of tan and the value of sine. Okay, so let's have a look. So using our cast circle, we know that tan here is positive. Tan is positive, and tan is positive in this section and in this section. Okay, what else do we know? We know that sine is negative, and sine is negative in this section and this section. So the only quadrant where both are true is this quadrant here. And in that quadrant, what is cos? cos is also negative, which means that my answer is going to be cos of b is minus root 3 over 2. So that example really using our cast circle more than our reference angles. So we're not actually working out what b is, but we're using a cast circle to see whether it's positive or negative. And you can see in that example you had to look at the value for tan and the value for sine and match them up in terms of the quadrants to tell you which quadrant you were looking for. So the overall things to look for in these questions are your steps, first of all. These are the key things. So see the quadrant where the answer is, then ignore the sign and find our reference angle, and then sketch those onto the unit circle and find our two solutions. Remembering as well that your reference angle is that acute angle to the horizontal. It's really, really important. And you can see in the few examples we've done here, we get our reference angle, we sketch that in, so then we make that connection between the reference angle and the total angle that we're looking at. That helps us then in solving these equations with our two solutions that we have. It's important then that we just get a grip or get kind of a handle on these questions now, so that when we come then to some later ones, which we're looking at in the last section, that we're kind of already able to do these ones already.